Denver built one of the most advanced airports in the world. But a nearly $300 million baggage system kept losing, crushing, and throwing bags. The runways were ready. The terminal was ready. The control tower was ready. The airport still could not open. But the airport could not open because its baggage system kept losing, crushing, and throwing the passengers' bags. This was not a small regional terminal waiting for a few conveyor belts. Denver International Airport was designed on an enormous scale. It covered roughly 50 square miles, with 3 concourses and gates located up to a mile from the main terminal. It was the first major new airport built in the United States since 1974. Moving thousands of bags across that distance with ordinary tractors and carts looked slow, expensive, and outdated. Denver wanted an airport built for the future, and the baggage system was supposed to be one of its greatest advantages. The idea was simple to describe and extremely difficult to build: one fully automated baggage network for the entire airport. A checked bag would be loaded into its own high-speed telecart, identified by sensors, routed by computers, and sent through tunnels directly toward the correct aircraft. On paper, it was extraordinary. More than 17 miles of track, 5.5 miles of conveyor belts, 4,000 telecarts, 5,000 electric motors, 2,700 photo cells, 59 laser barcode reader arrays, more than 300 radio frequency readers, and over 150 computers and communication systems. The goal was equally bold. The network was expected to carry as many as 70 bags per minute, with telecarts moving at speeds of up to 24 miles per hour. A suitcase checked at the terminal could reach an aircraft in about 20 minutes. Fast transfers would help airlines turn planes around more quickly and make tight connections easier. But there was a warning buried beneath the blueprint. As early as April 1990, consultants told Denver that there was not enough time to design, install, and test an airport-wide automated system before the planned October 1993 opening. A second consultant expressed strong reservations and recommended using a different, simpler system for each concourse. Under that proposal, one concourse would use high-speed conveyors, another could use automation, and the third would rely on conventional tractors and carts. Denver initially accepted the warning and chose conventional baggage handling across the airport. Then the plan changed. In July 1991, the city decided it wanted one common automated system serving the entire airport. The technology was still unproven at this scale, and it would have to be completed and tested in less than 2 years. Denver moved forward after receiving assurances from airline baggage experts that it could be ready in time. The contract went to BAE Automated Systems. By May 1992, the company had a contract worth roughly $196 million to design, build, and test the network. But while the airport was rising from the ground, the baggage project kept changing around it. Carousels were relocated, extra conveyors were added, oversized baggage sections were redesigned, airport layouts changed. The contractor said it did not always receive access to work areas when promised. Denver accused the contractor of falling behind. The contractor argued that Denver's changing requirements caused repeated redesigns. The airport, the machinery, and the software were all being built at the same time. That meant every late decision could travel through the entire system like a crack through glass. By May 1993, only months before the scheduled opening, a city engineer reported that development had not even begun on a key software system needed to control and route the telecarts to their correct destinations. The physical network was huge, but the real challenge was information. The computers needed to know where every cart was, whether it was empty or full, which bag it carried, where that bag needed to go, and which route was clear. Thousands of moving parts had to remain synchronized every second. And when large-scale testing began, the beautiful concept turned into mechanical chaos. Bags were loaded into telecarts that were already full. Some fell onto the tracks. Conveyor belts continued feeding luggage into areas where bags were already jammed. Sensors failed to detect the pileups. After the system restarted, the software sometimes lost track of which carts were full and which were empty. Other failures appeared across the network. Conveyors and telecarts were not synchronized. Luggage was misrouted. Carts collided and locked together. Empty carts were not always where the system needed them. A breakdown in one area could spread because the entire airport depended on the same tightly connected design. The first large-scale test in February 1994 produced major failures. Consultants concluded that extensive testing would be required to debug both the software and the hardware. Denver was no longer dealing with a list of minor defects. It was dealing with a system that could not yet be trusted with a live airport. The opening date moved from October 1993 to December, then to March 1994, then to May. Finally, the opening was postponed indefinitely while engineers tried to make the baggage network work. In total, the airport opening was delayed 4 times. Every month, the airport stayed closed. The financial pressure grew. Denver was operating the old Stapleton Airport, maintaining the new airport, and servicing debt on a facility that was not carrying passengers. Government auditors projected a deficit of almost $19 million per month during part of the delay. The baggage system's own cost rose from about $195 million to more than $290 million. And that was only the machinery, software, modifications, and construction connected to the system itself. A later government review found that the roughly 16-month delay added about $300 million in capitalized interest to the airport project. In other words, Denver was paying heavily not only to fix the system, but simply because the airport remained unfinished for longer. Eventually, the city made the most practical decision available. It began building a backup system using ordinary conveyors, tractors, and carts. More than $50 million was committed to the alternative, while engineers simplified the automated network. The original performance requirements were reduced. On some lines, the planned capacity was cut from 65 bags per minute to 30. The dream of one seamless airport-wide machine was replaced by a hybrid system designed primarily to get the airport open. The backup arrangement was hardly elegant. Bags would move through conveyors, staging areas, tunnels, tractors, and carts. But unlike the grand automated vision, it did not require thousands of components to behave like one perfect machine. On February 28, 1995, Denver International Airport finally opened. But the revolutionary airport-wide baggage system, described in the original plan, was not operating as promised. Automation handled only parts of United Airlines' outbound and oversized baggage, while conventional tractors and carts served other concourses. The project is often described as a failure of technology. But the deeper lesson is about decisions. Denver did not simply automate a stable, proven process. It attempted to create a massive, tightly connected system at an unprecedented scale, inside an airport that was still changing, against a deadline experts had already questioned. The city also made the system a critical path. The terminal could be finished, the runways could be finished, the gates could be ready. But without reliable baggage handling, the airport still could not perform its basic job. Automation can make a system faster. It can reduce labor and coordinate work humans could never manage at the same speed. But it can also make failure faster, especially when every component depends on every other component working perfectly. Denver International Airport eventually became an enormous success. In 2025, it handled more than 82 million passengers and ranked among the busiest airports in the world. But beneath that success remains a warning written in steel, software, and abandoned ambition. The most expensive mistake was not dreaming too big. It was treating an unfinished experiment as if it were already proven infrastructure. Every giant project has a hidden story beneath the blueprint. Subscribe for more engineering failures, expensive mistakes, and the systems quietly shaping our world.